What is up, guys? We're going to go over the two different examples today. Example 12. So we'll start with example 12. We have a modified atwood machine, which is in the setup that you see on your paper. Okay. Anytime you have a pulley and one of the sides of that pulley is on a flat table, that's called a modified atwood machine. All right. So like you see right here, we want to make sure we treat both those blocks as part of the same system, or a group of objects, which is our definition for system. So if we look at this, block B can only go up and down. So those are the only forces we're going to worry about. So it has the weight of B right there trying to pull it down. Block A has no friction, okay? And block A really, we could include this tension force if we were looking at just each individual block, but because we're looking at the whole thing together, that rope is like, its only purpose is tying those two things together. So we don't need to worry about the tension force. We just need to worry about what's trying to move our system, what's trying to stop moving our system. So the weight of block B is pulling it down. So if we're being asked, find the resulting acceleration, there is Newton's second law. We know we're dealing with forces and how do they make things accelerate. So Newton's second law is how we do that. And the only force acting on this, trying to make it move, is the weight of block B. So I'm going to put weight of block B right there. And then the mass of the entire system, that's the mass of all the things that are moving together. So that's mass of block A and mass of block B put together. Okay? And now I just need to solve for A. So the one thing I need to do is this weight right there, we can express that a little bit differently with our equation for the force of gravity and weight on an object. So mass of B times the pull of gravity, G. And that's the only thing we changed, so everything else we just carried down. And now we're trying to solve for A. Okay? So when I solve for A, I end up with mass of B on top, mass of A plus mass of B on the bottom. All of that is being multiplied by the pull of gravity. It's written like that in those parentheses and stuff just to look nice and clean. Okay, and it makes kind of your numbers easier to plug in here in a second, which you'll see. So if I want to now solve for this, because I actually know what the masses of my two blocks are, well, when I plug in my numbers, we get acceleration equal to mass of block B is 5, A and B together is 20 kilograms, and then the pull of gravity on planet Earth is always 10 newtons for every kilogram. Okay? So our answer ends up being 2.5, and then it's an acceleration, so newtons per kilogram or meters per second. All right, so yeah, modified atwood machines have a mass on a table. Just one of them. The other one's hanging off. All right.